Welcome to Beans and Bedrock.
Ever opened a Java class and feels like you walked into the house of cards of the code? Or to be more precise in coding language, the khichdi of the code? It is, let's say, it is handling the database connections like this, or it is calling some third-party API. Here we are calling the AWS Bedrock, or it is saving some sort of things in a database, or it is sending an email to the email by using any of the client. So just imagine if someone asks you to do the changes at a schema layer of the DB, or someone asks you to do the change in the email client. So what will happen? One small change and one mistake and the entire code will stop working. It will break. Isn't it the fragile nightmare that keeps you awake at a night? I have been there. I have been there, man. I spent countless nights staring at a code that was impossible to maintain. But today, we are going to clean this up. We are going to master the solid principles. I would say the holy grail of clean, scalable architecture, whether it's single responsibility or dependency inversion. We are going to untangle this maze so you can finally write code you are actually proud of. My name is Anupam, and I am here to make sure you don't make the same mistakes which I did in early my career. If you are ready to level up your engineering game and stop fearing your own code base, hit that subscribe button and let's get to the work. Let's start with the S. So, S stands for single responsibility principle. Right now, this, in a simple words, let's say there is a chef who is trying to cook, who is cleaning, and who is serving the tables simultaneously. And as you know, one mistake ruined the whole meal, correct? So, in real life, this is that one huge Spring service class you have that is trying to parse JSON, run business logic, execute raw SQL, and send a confirmation email. We need to break this apart. We'll apply a single responsibility principle to give each distinct task its own dedicated home. So, what we did as part of this, yes, if we go to the architecture, okay, let me show you the first architecture which we have. This document processor, it literally does everything like what we discussed earlier, right? Then, if at all we move to the S, right, we have the document processor, the orchestrator. Then we will be having one separate class for the document repository, then one for AI extractor, whatever the call we did, and the other one is for the notification service, which is alerting only. If at all we go into the implementation part, so if you see, we have this document repository class, which is save summary and fetch document, which has these two methods. AI extract has extract text and it is calling some sort of AI methods or AI API calls. And then we have this notification service, which is responsible to send alerts, send emails, and all the things. So basically, we divided one large God class into three different classes. Similarly, we can divide whatever the class we will be having into the different small classes so that each class has its their own responsibility. So this is known as a single responsibility principle. Okay, let's move to the next part, which is O, open close principle. So just imagine you buy a new TV at your home. To install that TV, you will not mess with your wall wiring or the main power box, right? You just plug it into the wall socket and switch it on. Similarly, software should work the exactly same way, I would say. It should be open for extension but closed for the modification. And this is what the open close principle tells us. You remember in our old code, here we have this notification service which is sending the alert, which is sending the basically email, right? So imagine instead of sending an email, someone came from the product team and asks us to add the new functionality to send an Slack message as well. So in that case, instead of adding if else conditions over here, like if the message type is email, then send an email, or if the message type is Slack, send the Slack message. If at all we are doing this, then we are violating the open close principle. Instead of that, what we can do is we have this notification service. What we can do, we can create a notification channel interface which has a send method. We can create two different subclasses or implementing classes for this particular interface, which will have email and Slack. To go into the code for this, we have this notification channel interface. We have this email notification channel implementing notification channel and Slack notification channel implementing same notification channel interface. However, we have the sending email and sending Slack message, two different distinct implementing methods. So yeah, basically this is the open close principle. So in sum up, your code should be open for extension but closed for the modifications. Okay, let's move to the L part, which is Liskov substitution principle. Actually, this one sounds more academic, but it's purely a common sense, I would say. Imagine you ask for a cup of coffee, okay? But you get the orange juice inside the cup of that coffee. It looks correct from the outside. It is perfectly fine. But it is not what you wanted at all. Similarly, subclasses must be completely substitutable for their base classes without breaking the system. For example, let's say in our tech world, let's say we have this AWS AI provider or Bedrock provider, which works fine when since it's a cloud provider. If we upload the files which are more than let's say 1 MB or anything, it works perfectly fine, right? But for our local test, let's say we have created a local mock provider, and if at all we are throwing the unexpected runtime exception for the large file, our orchestrator will crash. So how we can fix this? We can fix this by realizing subclasses must behave predictably. So basically, we standardize the contract by explicitly throwing document to large exception. So the orchestrator accepts it and handles it gracefully. Yes. So this is what the Liskov substitution principle. Okay, let's come to the I part now. So what exactly I stands for is interface segregation principle. What exactly it is? Okay, imagine you went into the restaurant, you order a thali. It, it will come with the 15 different bowls: dal, sabzi, curd, papad, pickle, sweets, and 3 types of rotis. Even if you want to eat only the dal and rice, the waiter forces you to take the entire tray. You have to move all those bowls around just to reach that one you want. In our technical space, what we say this is the fat interface. It forces you to depend and manage things you didn't even ask for. Let's imagine in our app here, what we have is we have the document repository, and if at all we add fetch, sign document, and get audit history, all these methods inside one single document repository, it will become the fat interface. So instead of that, what we can do is, okay, what's the problem with this fat interface? First up, and at first thing, let's say we have two different things to do. One is auditing and the other one is read only thing. So one class is only fetching the requirement of one class is to fetch documents only, and the other class is responsible for or the other class requirement is sign the document and get audit history of that particular document. Now consider the first class. If at all we force first class to implement this document repository interface, and we just add the empty implementations for these two, then it will be it's kind of a uh, extra burden for that particular class. So what we can do for this? What we can do is we can simply implement two different interfaces. One is read only repository, which has document fetch method, and the auditable repository has the sign document method and get audit history method. So wherever standard document repository implementing read only repository, so it is only fetching the details, and wherever it is needed to sign the document or audit history, let's say enterprise document repo, it will implement both the interfaces. It will write all the classes over there, all the not classes, it will write all the methods inside that, and we are ready to go. So this is what the interface separation or segregation principle we can say. Yeah. Okay, let's move to the next part and the last part, which is deep dependency inversion. Okay, let's say if document processor uses the new keyword to create the bedrock provider or LLM provider, it is automatically went into the tight coupling part, right? You are cementing that specific implementation into your class. If AWS goes down, or let's say we decide to go with the other LM provider in future, then we must rewrite the high level orchestrator logic, correct? That's the basic trap, I would say. Yeah? What else we can do? Instead of depending, instead, what we can do is we can depend on abstraction, not the conservation. We inject the required interface into the processor via its constructor. You only tell the framework, hey, I need to use XYZ LLM provider. And then the framework, like Spring Boot, wires it all up at a runtime. You swap providers just by changing the config file, right? So let's go and check what exactly the implementation we have. Okay, we have this object references created over here. Instead of creating the objects, we are creating the references and making it final. What exactly we are doing here? We are doing the construction injection over here. We are not using new keyword inside the class. We are passing the types of the objects from wherever we are, from whenever we are calling this particular document processor, or wherever we are creating this document processor. So if at all we send, let's say, Claude LLM provider, then we will have the Claude over here. If at all we are using Bedrock, then it will be a Bedrock. If it is any third party thing, then the third party thing will come here. And we can do the extraction. We have the similar things implemented over here for the repository and notification service. These are also not the objects which are created by the new keyword. We are injecting these objects over here. Yeah, so this is exactly, we say, the dependency inversion principle. So here we are at the final stage. Look what we built together. Went from that tangled, literally doing everything class, from the decoupled core class. Yeah. So remember, great code isn't just about making the machine understand you. It's about protecting your future self and your team members. Yeah. So, which of these principles do you catch yourself violating the most? Be honest. Let me know down in the comments. I would love to chat with you about it. Keep building, keep learning, and I will catch you in the next one. Thank you.